Today we're going to be looking at the review for Unit 7, which was on constructions, congruence, and proofs. Now this test is not an easy one. You'll want to take your time, take a look at the problems, make sure you read all the answers fully, know what the problem is asking, and then try to answer it. Also remember that you can keep your notes open. You can use your notes for this test. So one very particularly helpful one might be your geometry toolbox. Keep this one handy. And this review is posted in the class. So I do recommend you go in and give it a try before looking at this video, before watching this video for the answers. Give it a try first, and then come back and go through it and see how to do the ones you didn't know how to do. So go over there right now, take the review Kahoot, it's in Kahoot, and then come back here and we'll go through the problems. Okay, here is problem number 1. What is the missing side length of this right triangle? So for side lengths of right triangles, we use the Pythagorean theorem, which looks like this: a squared plus b squared equals c squared. Now the key on this one is figuring out which ones are the legs and which one is the hypotenuse. The hypotenuse is always c, and the hypotenuse is the one that's opposite the right angle. So this one is c. That means these two other ones must be the legs. So this is actually what we need to solve for. We need to solve for b. So we'll put in 12 for a and 13 for c. 12 squared is 144. 13 squared is 169. Now we need to solve for b. So we're going to subtract 144 from both sides. We get b squared equals 25. We square root both sides, and we'll get b equals 5. So that's our answer on this one. The missing side length is 5. Number 2. Are these two triangles congruent? If so, what proves it? So let's take a look at these two triangles. We have this one ABC and this one LMN. And we have an angle and the side between them. So it's an angle included side angle. Now we have a congruent angle over here, a congruent side, and a congruent angle. So we also have angle, side, angle over here. Angle, side, angle, angle, side, angle. Now we need to ask, is angle, side, angle is this a valid triangle congruence rule? Well, if we look back at our triangle congruence, not triangle congruence, but just our geometry toolbox, you see angle, side, angle is indeed valid. Remember, if we include the side or include the angle, so SAS and ASA are both included in triangle congruence. These are the ones that are not. AAA and SSA do not guarantee congruence. So since ASA does, we will say yes, this is congruent by ASA. Look at problem number 3. The blue polygon was constructed using only a straight edge and a compass. Okay, so we have this polygon right here. What is the name of this polygon? Well, we have to think back to our quadrilaterals, because we can see this is a 4-sided shape. And we see our options here are rectangle, rhombus, isosceles trapezoid, and franc, which probably isn't it. If you'll recall our rectangle definition, that involved right angles. We needed right angles at all the corners. So we don't have any right angles marked here, and we haven't gone through what's necessary to construct the right angles. Let's look at what we do have. We have what look like congruent circles. In fact, they are congruent because we've taken the center and drawn a circle, and then we've put the center on the circumference. That means the radius of both of these circles are the same. And that is a radius, and that is a radius, and that is a radius. So these are congruent circles. The sides are all radii of those congruent circles. So this is a quadrilateral with 4 congruent sides, which is what a rhombus is. Next problem. Given JKLM is congruent to RSTU, which of the following must also be true? Well, we know that congruent parts of congruent objects must be congruent to each other, and we have to put these vertices in order, which means angle J and angle R are going to be congruent, angle K and angle S, angle L and angle T, angle M and angle U, and also all the line segments in between them, JK and RS, KL and ST. You might see them backwards, LK and TS, but they have to be in the same position, so second and second have to be the same. So let's look at the options out here. Angle L and angle R. Angle L is in position 3, angle R is in position 1. So that one is not the case necessarily. ML and UT, line segments ML and UT. So ML is in 4, 3, position 4 and 3. UT is in position 4 and 3. So this one looks like it might be a good option. But let's check the other ones just to make sure. JK and ST. JK is in 1, 2. ST is in 2, 3. So nope, that one doesn't match. Angle M and angle S. M is in position 4. S is in position 2. That's a no. So this is the only one left. That's our answer. Question number 5. Write this expression in simplified radical form. So this is kind of an older problem. We've been doing these for a while, or maybe we haven't looked at them very closely in a while. But these became relevant again when we started looking at Pythagorean theorem. We need to reduce and simplify radicals. So remember the way we did that was we divided it up into factors. We asked, what does 50 divide evenly by? What does 17 divide evenly by? And then we draw a little tree. So if we have 17, well, that's actually a prime. That doesn't divide by anything. That's just 17 and 1. So we stop there. But 50 divides by 25 and 2. 2 times 25 is 50. 2 is prime. And 25 further divides by 5 and 5. 5 times 5. And since we're looking at a square root, we're looking for pairs of numbers. So since we did find a pair, that pair can come out in front of the root, and we get 2 times 5 root 2. This 5 came out in front. This 2 stays underneath the radical. So 2 times 5 is 10, and that leaves a root 2 there. The 2 root 17 doesn't change because we couldn't simplify it at all. 17 is already a prime. So we get 2 root 17 plus 10 root 2. That is this answer right here. Now, if you're not sure on these, if these ones are a little bit confusing, remember that a good way to check this out, just to check your answer, is to put it in your calculator and calculate a decimal. You can calculate a decimal for each one of these answers and see which one matches. So if I do 2 root 17 plus 2 root 50 in my calculator, I get about 22.388 on and on. Now if I look at this first answer, root 34 plus 10, root 34 plus 10, I get 15.83. That doesn't match 22, so it's not that one. If I look at the blue one, 2 root 67, I get 16.3707. That also doesn't match 22. This one is in decimal form, and this we wanted it in radical form, so that one's not true either. This is the only one left. Let's put that in our calculator and see if we get the same decimal. 2 root 17 plus 10 root 2, I get 22.388. That does match. So remember, you always have that option. If you don't remember how to simplify a radical, you can calculate out the decimals and compare them. Problem number 6. Which of the following statements is true about the picture shown? Okay, so it looks like we may have some congruent triangles here, possibly. We have 2 congruent angles marked, 2 congruent angles marked up here. And then you also may remember we have this line that's shared in common, a coincident line. And we have that reflexive property that says an object is congruent to itself. So essentially we have an angle, and a line, an angle, and a side, and then an angle, and a side. So we have AAS. Was AAS a valid triangle congruence postulate or theorem? AAS? Let's see. Triangle congruence here. AAS, yes, it is. AAS is a valid triangle congruence postulate. So let's see if that's one of our answers. Let's see. Triangle ABD is congruent to triangle CBD by AAS. That looks like it's going to be our correct one. SAS, so this is the same congruent statement but by SAS. We'd be looking for 2 sides that are congruent. The only side I see that they have in common is this one. None of the other sides are marked. So it's not that one. Measure of angle DAB, so this one, measure of this angle, is congruent to measure of DBA. So this has 2 marks. This one has 1 mark. Those don't match, so that isn't a congruence mark. And our last option here, triangle ABD and CBD are similar, but there's not enough info to prove congruence. Similar was when we encountered AAA. Those were AAA triangles. Remember, you could dilate those up or down, make them bigger or smaller, but they're the same shape. This is not AAA because we also have a side in common. We actually could state that these third angles are congruent, and we would have AAA, but we also have an additional piece of information which guarantees congruence now, because we have that side in common. So there is enough information with that side to prove it by AAS. A little bit tricky. Let's look at number 7. A proof is provided for the following problem. Fill in the missing justification. Okay, given the following diagram, prove that triangle CBZ, this one CBZ, is congruent to triangle CMW. So this triangle up here is congruent to this triangle down here. Okay, first that says angle B and angle M are congruent, so those are marked, and that's given. All right, makes sense. Second step is line segment MC is congruent to line segment BC. MC right here is marked with 1 tick, BC is marked with 1 tick, so that's also given. Easy enough. And then it says angle MCW, this one, angle MCW, is congruent to BCZ, this one right here. So we could mark those. This angle and this angle are congruent, and maybe we'll put a little tick on them so we can distinguish them from the other one. And if you'll recall, these are intersecting lines, so we have vertical angles theorem here. Vertical angles theorem guarantees that these 2 angles are equal to each other, or they're congruent. So now it says we can prove that triangle CBZ is congruent to triangle CMW, and we're asking, what is the justification? Well, let's look. We have an angle, and a side between them. That's angle, side, angle. Angle included side, angle. Down here we again have angle, included side, angle. So these are congruent, these sides are congruent, these angles are congruent. Angle, side, angle. We just have to ask, is angle, side, angle valid? Is that a valid congruence postulate? Right there, angle, side, angle, it sure is. Remember, included side or included angle is included in our valid congruence postulates. So angle, side, angle was our rule here, and that's the answer. Obviously not this one. Hypotenuse leg is only valid for right triangles. We don't have any right angles marked here, so that one couldn't be it. And then CP-CTC, this is corresponding parts of congruent triangles are congruent. Remember, we only use that after we've already proven congruence. We can't prove congruence with it. We can't prove congruence of full triangles with it, so when we do a triangle congruence, it isn't going to be that rule either. This one has to be ASA. Let's look at problem 8. What is the line segment, or what is the length of line segment BC? Round your answer to the nearest tenth. So we have what looks like a right triangle in the coordinate plane. This length right here, BC, is what we're looking for. And we can use Pythagorean theorem again. So our hypotenuse needs to be side C. The other two we'll call A and B. And we can count the length of the sides here. 1, 2, 3 for A, and 1, 2 for B. So if we have A squared plus B squared equals C squared, we'll put 3 in for A, we'll put 2 in for B, and we'll get C squared. 3 squared is 9, 2 squared is 4, equals C squared. 9 plus 4 is 13, which equals C squared. We shall root both sides, square root, to get rid of that square. And then this one asks us to round to the nearest tenth. So we can actually put this one in our calculator. Root 13. I get 3.605 ... We're rounding that to the nearest tenth, which rounds down. So 3.6 is our answer. Remember, on these Pythagorean theorem problems, the most important thing is to make sure you get the legs in the right place and the hypotenuse labeled C. The hypotenuse is the side opposite the right angle. Okay, problem number 9. Are these two triangles congruent? If so, what proves it? So let's look at what we have with these two triangles. We have a side that's congruent, we have another side that's congruent, and we have an angle that's congruent. This angle is not between those two sides, so this looks like a side-side not included angle. Side-side not included angle. So looking at our answers, we have an SSA, we have a not enough information, we have ASA. I bet we can rule that one out because I only see one angle marked, so we don't have two congruent angles. And then CP-CTC, we already discussed why you can't prove triangle congruence with that one. That one comes after a triangle congruence is already proven. So we're down to these two. Basically, we need to determine, is SSA a valid congruence postulate or theorem? Let's take a look again at our geometry toolbox. SSA here is right here. It guarantees neither congruence nor similarity. This is a no. SSA does not guarantee congruence. Remember, that was because there were two different options. You could swing that leg in one direction or out the other direction. So there are two options. It doesn't guarantee congruence. So this is a no, not enough information. And our last problem on this one. What is the midpoint between these 2 points? Remember, we found midpoint by averaging the two values. So our x value, we add them together and divide by 2. 5 plus -1 is 4. divided by 2 is 2. We do the same with the y value. 4 plus 12 over 2. That's 16 over 2, which is 8. And our overall answer here is 2, 8. So that wraps up the Unit 7 review. Let me know if you have any questions, if there's anything you want to work on, anything additional you need help on. You can email me or text me. And you are going to do great on the test tomorrow.